Well, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a cool lesson on slope-intercept form and how to evaluate a function graphically and also algebraically. Okay, it's function evaluation, but we're going to do it graphically, and that's why you have a graph right here. So given a function, f of x is equal to 1 half x minus 1, all right, which is in slope-intercept form. Find f of 4 graphically using the graph and also do it algebraically using the function itself. Okay. In the previous unit, we already discussed how to evaluate it algebraically, so that's the easy part. The new part is, how do you do it graphically? So the very first thing we do is we understand that f of x is the same thing as y, so y equals f of x, which means that the function that we're trying to evaluate, or that we're graphing here, is y is equal to 1 half x minus 1. Okay, where if you look at this, the slope is 1 half, the slope is equal to 1 half, and the y-intercept is negative 1. All right, so this is what we know. It's in slope-intercept form. We know that, like I said before, slope-intercept form is y equals mx plus b. All right, and so it is in slope-intercept form. So you see the slope is 1 half, which means rise 1, run 2, all right, from the y-intercept to negative 1. So what we do is you plot the y-intercept first, always on the y-axis first. This is the y-axis here, and this is the x-axis over here. And the y-intercept here at negative 1 is down 1 unit on the y-axis. So you plot that, and then you use the slope up 1, right 2 from that point. So put your pencil at negative 1, go up 1, right 2, up 1, right 2, okay, and then reverse it. Go back the other direction. Okay, so go down 1, left 2, down 1, left 2. Okay, so use your slope and plot many points. Okay, plot many points using your slope here. Okay, 2 points determine a line. However, you can see the line form when you plot a bunch of points. So go ahead and use your ruler now. You have to use ruler because you have to be accurate. The graphing method requires accuracy. Okay, algebraic method does not. What we're going to do secondly, but the graphing method does. So we want to find f of 4. Okay, well, f of 4, well, let's see here. Let me highlight that. So right here, what that means is that, hey, what's the y value when x is equal to 4? This is your x value here. So what you do is you find 4 on the x-axis, and it's 4 units to the right. And all you do is to find the y value is you go up to the function, okay, which is the line, okay. When I say function, I'm talking about the graph of the function, the line. So you go up to it. I'm going to do that visually. I'm going to draw a dotted line here. And then you move to the y-axis and you find its y value. Okay, so when x is 4, y is 1. Right there. This point on the graph is 4, 1. So f of 4 is equal to 1 on the graph. Okay, I just evaluated the function graphically right there. You take the x value, start on the x-axis, wherever the x value is on the x-axis, you go to the function, move to the y-axis, and read the value, and it's at 1. All right, so f of 4 equals 1. Now, algebraically, when we did this in the previous unit, I said, okay, you take whatever function they give you, which is f of x is equal to 1 half x minus 1. I'm going to put x's in parentheses here. Because what you have to do is you have to take your x value and you have to substitute it in wherever you see x. Okay, and you got to take 1 half times that value and then subtract 1. Well, if you're trying to find f of 4, okay, let me write down f of 4 here. You're going to take 4 and substitute it into the function. So you're going to take 1 half times 4 minus 1. Well, as you guys know, a half of 4 is 2. Right? 4 divided by 2 is 2. So I'm going to bring a 2 down here. And then I got to subtract 1. Well, 2 minus 1 is 1. So we say that f of 4 is equal to 1. This is the algebraic technique. Algebraic. So I did it by using the graph first. So I did it graphically. That's why I gave the title of the lesson, Evaluate the Function Graphically. We'd use the graph right here. Okay, using the graph. And then afterwards, we verify it by doing algebraically, and the results should match up. And so notice that the y value is 1 here, and the y value, look right here, it's 1. It's 1 on the graph. Okay, so you go up to the function and to the y-axis. That's all you do. And what we do is, let's get some experience on that. We're going to do it graphically and then algebraically, and the results should match. Results must be the same. Okay, I'm talking about the algebraic result and the graphical result. If they don't, then you're doing something wrong somehow. Okay, so let's do it again. Let's graph this next function here. F of x equals a negative 1/3 x plus 1. So we graph the y-intercept first. Okay, the y-intercept is 1. So we plot that at 1. I always plot the y-intercept first. Now, slope of negative 1/3, negative 1/3, this is your slope here, is down 1, right 3. Okay, that negative, just pull it up top in the numerator and write it as negative 1 divided by 3, and that's rise over run. So we're going to go down 1, right 3. You just count. Down 1, right 3. Don't worry about it if you're off the grid. Okay, now reverse it. Up 1, left 3. Up 1, left 3, and you're here. So you can see the line form. All right, get your straight edge out and draw an accurate line. Now, if you don't draw it accurately, then when you evaluate your function graphically, then you might get the wrong answer. F of negative 3 is when x is negative 3. So we find negative 3 on the x-axis, which is right here. Okay, in red, check it out. I'm going to go up to the function and then move to the y-axis. Okay, and notice that y equals 2. So I know that the function should be equal to 2 at x equals negative 3. That's how you do it graphically. So just move to the function, starting at the x value, go up to the function, and then go to the y-axis. It's that simple. Over here, algebraically, we got f of x equals negative 1/3 times whatever x is, all right, plus 1 more. All right, when you find f of negative 3, you substitute it in. All right, one more time, you take this value and just substitute it in. Okay, right in there. And you take negative 1/3 times the x value. And remember, it's not 3, it's negative 3, so keep track of your signs right here. And then you simplify a little bit. I see a double negative right here. And 1/3 of 3 is equal to 1, and plus 1 more is equal to 2. And notice that they are the same. Okay, it must match. They must be the same. And they do. Your algebraic expression or your evaluation must be the same as what you get on the graph. And if you don't get the same values, you made a boo-boo, okay? So, remember that. Okay, on the next one here, we got a slope of negative 1. And we got a y-intercept of 3. Now, a slope of negative 1 is negative 1 over 1, which means down 1, right 1, from 3, which is a y-intercept here. All right, so let's graph 3, a y-intercept of 3. That's 0, 3. And then from that point, we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Reverse it. Go reverse the slope. Up 1, left 1, up 1, left 1. And guess what? You can see the line form, right? I keep saying that. So get used to that. So use your straight edge only and plot an accurate line. All right, and now's the time to evaluate your function. X is now 1. So when we try to find f of 1, we locate 1 on the x-axis. Okay, it's right there. Between 0 and 2 is 1. You go up to the function, and then move to the y-axis, and guess what? Y is 2. So when x is 1, y is 2. All right. Then you back it up with the algebraic function. So f of x is equal to a negative of whatever x is plus 3. So one more time, you take whatever x is and you substitute it in. So when you find f of 1, you take negative 1 and add 3 more, and you get 2. Oh my God, it's the same value. Okay, so whether you evaluate the function itself or on the graph, it gets the same value every single time. Okay, I'll do a few more, and then the rest is up to you. Okay, so let's graph this function here. The y-intercept is negative 4. The slope is 2, which is 2 over 1. So I go up 2, right 1. So up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, Okay, just keep on busting out the slope and graph your function accurately, and make sure you use a ruler. Okay, what's f of 3? So when x is 3, what's y? Well, let's find 3 on the x-axis. It's right here. There's your x value. You go up to the function and move to the y-axis. So y is 2. So there you go. That's it. And then as a function, you say f of x is equal to 2 times whatever x is. Notice I put in parentheses minus 4. So when you want to find f of 3, that means x is 3. Just take a look at it right here. X equals 3, right? And you just substitute it in. So you take 2 times 3, whatever that is, minus 4. Well, 6 minus 4 is 2. And so we say that f of 3 is 2. And notice they match. One more time, see? They match. They better match. They match over here too. Okay? Whether you do it graphically or algebraically, it's all the same thing. Okay, even if you have fractions, just go with the flow. Okay, so the slope here is 5/2 and the y-intercept is -5. So you start at -5 on the y-axis. You go up 5, right 2, up 5, right 2, and plot your line. Okay, step 2, we know that x is 2 here. So we want to find y when x is 2. So right here is 2. There's your x-axis right there, or your x value on the x-axis. It's 2 right there. Well, what's the y value at that point? Well, go to the y-axis. Okay, y is 0. So f of 2 is 0 in this case. And then evaluate it. F of x, let me write a little bit better here. F of x is equal to 5/2 x minus 5. So what's f of 2? Well, let's see here. You want to substitute it in. You want to take whatever x is, multiply it by 5/2, and then subtract 5. So 5/2 times 2 minus 5. As I taught you guys in the past, you can multiply first and then divide, or you can divide first like this. 2 divided by 2 is 1. 1 times 5, well, that's 5. Minus 5 gives you 0. Or you can multiply first. 5 times 2 is 10. Divided by 2 is still 5. Okay, and 5 minus 5 is 0. So you simplify and evaluate, and notice they are the same thing again. Okay? All right, so whether you do it graphically or algebraically, it's all the same thing. All right, so time for you to practice, okay? I want you guys to do number 6 through 10 right here, and then check it with me, okay? And check it with each other and do it together. Remember, your graphical results better match your algebraic. Okay? And this is how you evaluate a linear function graphically and algebraically. It's easy. All right, this is Mr. Ainsworth. I'll see you in my next lesson here in the unit on linear functions. Work hard, make yourself proud, do your homework, and make sure it's good quality, okay? Check it with me or check it with your partners, but make sure you check your work. Because doing your homework is one thing, doing it correctly is another thing. Remember that. All right. Talk to you in my next lesson. Bye-bye.